Greetings to all and welcome to the session 2 of week 9. So in the today's session we are discussing a practice on simulation software, a simple program. We are discussing a simple program using a Robodk software. So in the earlier session we have discussed the basic things of using Robodk software. So in the today's session we are discussing a simple program to generate a rectangular path. Here, a simple program using robotic simulation using Robodk software. That programs we are discussing here to generate a rectangular path using linear joint way. So the robot used for this creating this program is universal robot. The model is UR-E10, 10E. It has got 6 axes. Reach of this robot is 1300 millimeter. Payload is 10 kg and weight of the robot is 29 kg. Repeatability is 0.050. The tool used is paint gun. Typical application of this path is usually you can use it for painting, spray painting a rectangular object. So let us go directly to the software so that we can easily program the particular program. Go to the Robodk software here. Now, initially it will create a new station. If you want a particular file name, right click here, click on save as. I'll use a file name instead of new station. You can give it as rectangle. Click save. This will become rectangle here. If you want a particular name, you can save as to a particular name. So now, as usual, I'll go for inserting particular robot from the robot library. Go here, this symbol, open robot library. So earlier, as I said, you need an internet connection for downloading the robot. Without that, you cannot download any robot here. So the my robot brand is universal robot. I'll go for filter option. Go to the universal robot here. Universal robot. You have 7 models in the universal robot. So my model is UR-E10, UR-10E. Here is the UR-10E robot. It has got 6 axes. Reach is 1300. Everything what I have defined is this robot. So I'll just click on open. So the robot will be added to this initial reference frame automatically. It is downloading. You can see here. Okay, now I'll click this as right click, save as rectangle. Click on save. Now you go on inserting a tool here. So for inserting tool, I will go to the file, open. Here go to the library sample locals. Double click here. We'll get many kind of robots, program, everything here. I'll go for paint gun here as my tool. Search for paint gun. Here is the paint gun. You can see the 2 different paint gun here. What is this? The difference between these 2 things is this paint gun is an actual tool here. This is a tool. This paint gun is also a tool, but is model one. This is just like a 3D model we have designed in the CAD software and we have inserted. So this is the actual tool. This is the model of the tool. So we can see this difference, these things with the symbol. It is showing the 3D object here. It is showing the actual tool like. So you have to always go for a paint gun tool with this Robodk tool option, not for the object option. So I click on that and click on open. See here, the paint gun is inserted to the flange of the robot here. So automatically it will be attached to the flange. Now my arrows are looking very bigger. I will make it as smaller by pressing minus key. So this, in order to move the robot, you can use scroll down, scroll up, left click, rotate, like drag and rotate like this. So this point, as you know, TCP. TCP means tool center point. In my case, the tool center point is the end of this spray. It is a transparent spray painting device here. So this is actual my tool. Once you spray, it will spray like this. So this end of this one is considered as a TCP here. Now I'll give this hit here. I'll insert one target here. Target 1. So this target one, I'll rename it as home option. This is because this is the home position of the robot. So I'll rename it. We'll go for F2 option also. Rename. I'll make it as home. Okay. Now I'll move the robot to the approach position. To move the robot, as I told earlier, you have two options. Just press Alt, you can move manually, or if you know the precise value, you can go for a double click on the robot base. In this, my case, I will do by two method also. Both methods. I'll press Alt here. I will make this paint gun to paint the object. I'll click on robot base here. The parameter will come. I'll move the Y direction like this. I'll come little down. Here the joint movements. You can move the joints here like this. This is third joint. I'll make it as straight. Here, this paint gun, I'll make it as straight. By moving these joints. What are these 5 joints means? You have 5 joints here. 1, 2, 3, 4, and 5. If you increase or decrease the particular joint, here this is the first joint, this is the second joint, this is third, this is fourth, and this is your fifth, and this is your tool one is sixth one. So I'll make this paint gun straight. Now I'll give the new target here. I'll make this as approach, rename it. We can OK. So the two targets are created, home and approach. Now I'll start giving my path. I'll move the In order to achieve the targets, you need to carefully move the robots here. So this is my first point of the rectangular. I'll give it as new target, target 3. Now in order to achieve the, I will make this dimension perfect, because in order to create the rectangle you need a particular dimension. I will make it as full values here. Instead of this 1008.86, I'll make it as 1000, so that it is easy to create the rectangular path using this parameter. In the next step, 1000, I'll make it as 400. So now have varied the movement here. So earlier my target 3 was here. So I have moved little bit movement here. So in order to go achieve, in order to make this my particular present movement, present position of the robot as my target 3, because already I have created target 3 here. So now we have just moved the robot. So now I want to make this my present movement, present position of the robot as a target 3. You have to close this and double click on the target 3 here. The target 3 now, earlier it was there. So now again you have to achieve the particular moment. Double click on the UR10 here. So make it as 1000. This I'll make it as 400. This one I'll make it as 0. Now right click here, click on option. So the parameter with related to only target 3 will be displayed here. So now I'll click on move to target. Now your target 3 is updated, because I have changed it here. Initially I have created target 3 by just moving the robot, and I have clicked on this target option. So the target 3 has gone to means it has allotted all these parameters. After that I have little bit changed it. So in order to get means achieve that particular difference what you have achieved, the movement, in order to achieve that you have to click on right click here, click on option, and click on move to target. Now your target 3 position is updated. Now it is easier to create the rectangle here. So what I'll do is here, it has not changed here. I'll go for, again I'll go for option, thousand, 400. I'll make, okay, you need to change here, not here. You need to change here. I'll make this as 1000, and I'll make it as 400 here. So Again, I'll make this as 0 and I'll click on move to target. Now it has updated. Here also it is updated. You should not change here. You should change here only. That's what it is not moving. So everything will come with the experience. So I have learned here also, and you should also learn because this software is new one. You need to practice more and more to become familiar. Close this. Now I'll move to the next target. So this is the tool frame with respect to a reference frame. The tool frame is this one with respect to reference frame. The whatever the movement will give here is with respect to this to this. Now I'll varying these parameters to get the rectangular path. See, this is 1000. I'll make it as 500. 500. This is my target. I will not vary the y and z direction because in rectangular, only you need to change the only x in some direction and y in some direction to get the length and width. I have varied x here. I will make this as my target 4. Okay, the two things are achieved. The two corners I got target 3 and target 4. This is my two corners of the rectangle. Similarly, you need to create two more corners. So next, I'll move. I moved X here. Now I'll move Y. It was 400 earlier. I'll make it as minus 100 so that 400 0 to 400 400 plus minus 100 is 500. The length of this rectangle will be 500. Width also 500. So I'll increase this little bit more to 300. Otherwise, it will become square. 500 means it will become square. Now 400 plus 300, 700 length will come here. This length will become 700. So I will make this as my target. New target 5. That is my third corner. Similarly, now you have to vary x only. I'll make it as 1000. Earlier I have given x per corner or target 3. I have given 1000. Similarly, you need to maintain to get the rectangular path. Click on 1000. Here 4000. Make it as perfectly 1000. Otherwise, you won't get rectangular. This is my 1000 here. I have not varied any z direction at all. Only I have varied x and y direction according to my requirement. Now I will make this as target 5, target 6. Sorry. We can rename the targets as per as just like corner 1, corner 2, corner 3, corner 4. I'll rename it. Rename F2 option shortcut. Rename them as C1, corner 1. This I'll rename it as C2. This I'll rename it as C3. This I'll rename as C4. So I got all the 4 corners. Still our program is not over. Only I have created target. So in order to create the program, you must give, as I told earlier, you need to give any one of the 3 joints here. Now I'll start making the program. I'll click home here. This is my home position. This is my approach. This is the corner 1, corner 2, corner 3, corner 4. Now you have to allot the movement between these targets in order to achieve the program. So I'll click on program here. Once you create the program, automatically, as I told earlier, reference frame will come. This is the reference frame, and the tool will come. In case of this program, I have inserted paint gun. So earlier in the introduction class, I have not inserted tool, so the tool has not come here. Now I have inserted tool gun here. If you want to change the tool, in this case, I have only one tool. If you have more than one tool, you can change the tool here. If you have more than one tool, it will come here. can select the particular tool. Similarly, if you want to change the reference frame, if you have another reference frame here, if such as if you inserted any object here and that has got another reference, so we can change the reference frame also here using the set reference frame. Now automatically it has taken move joint move here. I'll delete that, it is not required. I'll go to the home position. Now for home position I need a joint move. For approach position I also need a joint move. Now for corner 1, from approach to corner 1 also I need joint move. Now here, in order to achieve the rectangle, you should move in a linear way only. So for the corner 1 to corner 2, you click on corner 2 here and click on linear joint. Instead of joint move, you have to click on linear joint here. Similarly, click on corner 3. Now the corner 2 to corner 3 also should be moved in a linear way. I click on linear joint here. Now for corner 4, also you need corner 3 to corner 4, the linear move. So here the movement has got achieved. Again, in order to complete the rectangular path, you need to go from the corner 4 to the corner 1. Yes, corner 1. So now you click on corner 1 and view again the linear joint. Now the rectangular path has achieved. You can see here. This is not yet over. You only if you run the program here, double click here, the program will run. It's fast. It is very fast. Make it in as and you can increase the speed of the simulation here like this. Now click on this program. See here, the program, the arrow is showing the which part of the program is running here. See here. Suppose if you have a rectangular object here, it will paint this object, which is the purpose of creating this program. Now it has moved to corner 4 and has stopped. Again it has come to the original position. So now I'll click on approach here. The program is not yet over, only it has created the rectangular path. It has come back to its original position. So I'll click on approach. From corner 4 to it has gone to the approach here. Click on approach and give linear joint way. So wherever possible, you must avoid the linear movement. Why? Because the singularity error will come. The singularity error I have given in your notes. What is singularity error means? At a particular point, the end effector means the tool attached to the robot will become unable to rotate or move because of its rotation. It has unable to reach the particular target, that is called as singularity. So in a particular moment, it is not possible to rotate the end effector because of its workspace limitation and rotation limitation. It is not possible to achieve the particular position. That is called as linear this singularity. So to avoid that, wherever possible, you must give this joint move. Not should not go for linear movement. So if you give the linear movement, the singularity error will come. Wherever possible, you can give only linear joint. If you have a particular linear joint, you cannot avoid that. So in case of your rectangular, you must give linear joint. But from corner 4 to approach, you should not avoid the linear joint because there must be a possibility of singularity error. So you can give the joint view. This is a random move. Joint movement means a random view. The linear movement means the robot will move in a linear way only. So to avoid the singularity, you must give. You must avoid the wherever possible. You must avoid the this linear movement. So from corner 4 to approach, I have moved in a joint way to avoid the singularity. Similarly, from approach, it has to go for home position. I'll click on home here. I'll give the joint movement as my movement. Now the program is completed. If you click here, everything the complete program will be executed here. From hope position, it has come to approach. The approach has gone to corner 1, corner 1 to corner 2, and corner 2 to corner 3, the corner 3 to corner 4, corner 4 to corner 1. Now from the corner 1 to approach or retract. From approach, it has to go for home. Now the program is over. This is the path where the robot has moved. In order to continuously run program, you just keep on loop here option and increase the speed here every time, simulation speed here. As I told, our program is over now. If you want to stop, right click and check on loop. Now you can also press escape. You see whether the program will be generated for this. The program has created already, but the program is needed to send it to the robot. So for that option, you need to click right click here, generate a robot program. So the program is generating. See, the program is generated. You can see this is your program. So you can see the move J means joint move. These are the parameters X, Y, Z and rotation. So what are the particular parameter? If you know the particular values of X, Y, Z, you can edit anytime here. You can directly edit here. According to that, it will change here. So this program is now in a Python. It is in Python software. So the Robodk will generate in a this program in a Python software. So it is now ready to send it to the robot. Now you can send this program to a particular your universal robot. It will move the same way what you have simulated here. So this is the very advantages of this simulation software, and you can vary these things parameter at any time. So that's it for today's session. Finally, I would like to thank my team, the moderators and all subject expert, and my fellow content developer for helping me to for making this video. Thank you. We'll meet in the next section. Thank you.